Hello everybody, this is Amber the math tutor. We're working on lesson 1-9, reducing fractions with factor trees. This is one of my favorite lessons to do. And we're doing part 1, factor trees and prime numbers. And honestly, I love factor trees. I could do them all day long. So I have these 3 little notes for you to keep us on track as we're going. I'm reminding you what prime numbers are. They only have factors that are 1 and itself. So examples would be like 7 and 13. The only 2 factors of 7 are 1 and 7. The only 2 factors of 13 are 1 and 3. Or yeah, not 1 and 3 are 1 and 13. And then 2. 2 is the only even prime number because it only has 2 factors, 1 and itself, 2. So let's move on to composite numbers. It's basically the rest, right? Composite numbers have factors other than 1 in itself. So an example would be basically any even number besides 2. So like 34, because it has 134 and it also has 2 and has other factors. And then how about 9, because it has 1, 9, and it also has 3. And then just like, I don't know, 100. That's a perfect example. It's a even number. So these are composite numbers. And then factor trees, we're about to do them down here. This isn't what a factor tree is. This is just my little hint to you. You have to keep going until it is all primes. And you're about to see what that means if you haven't seen factor trees before. So number 1, create factor trees for the following numbers. So let's start with 14. So basically you're just writing these as an expression of their factors. So what are 2 factors of 14? So 2 times 7. And then that's actually the only 2 factors. So it has 1 and 14, but then also 2 and 7. So we're going to circle them. I like to circle once we get to prime numbers. So 14 is really easy because it only has 2 other factors. Let's do 16. Usually with the even numbers, if I'm not, because I guess you could do like 4 and 4, but usually with the even numbers, I start really easy by doing 2 and then whatever it is. So 2 and 8. And then we keep going now because 8 isn't prime. So that's what it says. Keep going until it is all prime. So now we need to write 8. 8 can be 2 times 4. And then 4 is 2 times 2. So let's do number 25. That would, or I mean the number 25, it's just 5 times 5. Those are the 2 prime factors that it has, so that's it. It has 1, 5, and 25 as all of its factors. And then let's do 28. It's going to be 2 and 14. And then 14 is 2 and 7. And we could go on and on and on and on. I just wanted to pick some that we didn't have to take up the whole paper to do. And then I'll show you what comes next. So if you look at number 2, it says express the number as a product of primes. And I made this easy. I picked the 4 numbers that we did from the previous example. If we had a number here that we didn't already have a factor tree for, all we need to do is make a factor tree for that number. And then, so 14, let's look at it. 14 is 2 times 7, so that's what you write. 2 times 7. We already know that these are both prime, and this is a product of prime numbers. So that's how we write 14 as a product of primes. Let's look at 16. 16 is 2 times 2 times 2 times 2. And you could write 2 to the 4th power, but for what we're doing with this assignment, I'm actually going to have you write it out like this. Okay, so 25 is 5 times 5. And then go to 28. It's 2 times 2 times 7.